law of sines. And hang on to your hats because this is going to be a wild ride. So, sometimes, under certain conditions, the angle and sides that you have that you would use for the law of sines doesn't give you one unique triangle. It may give you two triangles, or it may give you no triangles. So this has to do with the relationship of the sides to the angles. So in a right triangle, this side A opposite the angle A is equal to B sine A. And you can work that out using using SOHCAHTOA, right? If the side A is less than that, you're not going to get a triangle because that side won't actually reach the other side of the triangle. If you get a value in opposite side A that's more than that, you could have two triangles, right? One with an obtuse angle here and one with an acute angle here. If your A is less than 90 degrees but side A is bigger than side B or equal to side B, then you're only going to get one triangle. If the angle that you have is bigger than 90 degrees, the opposite side has to be bigger than the other side. The side opposite the obtuse angle has to be the biggest angle in the triangle. If it's not actually going to make a triangle. So this only applies when you have two sides and a non-included angle. If you have two angles and a side, you're not going to get an ambiguous case because you can find all of the angles in the triangle, and therefore there's nothing ambiguous about it. What makes it ambiguous is that there are two possibilities for this angle. And the reason that happens, right, if we sketch out our unit circle here, right? So if I say that sine theta is equal to 1/2, I do my law of sines and I get sine theta, or sine A, let's say, equal to 1/2. Well, where on my unit circle is sine equal to 1/2? Well, it could be here at 30 degrees, but it could also be here at 150 degrees. There are two places on the triangle that have the same y-coordinate and therefore have the same sign. So, under certain situations, you have a possibility of having two different angles that are going to have the same sign. The easy thing about this is that once we check and we see that we have two solutions, we know that we're going to get angle A, like let's call it A1, and angle A2, which is 180 minus A1, right? If the first angle is 30 degrees, our second angle is going to be 180 minus 30, which would be 150. So, I have taken that information in the chart and put it in handy flowchart form. Ms. Moudiker says that this is the best way that she's ever seen to do it. So, I hope that works for you. So start here. So this is a case where we have some angle A and some side A and B. It doesn't have to be A and B. It could be C and B, or B and A. The point is that we have some angle, we have the side opposite that angle, and then we have another side. So first, check, is your angle greater than 90 degrees or less than 90 degrees? If your angle is greater than 90 degrees, you go this way, or is less than 90 degrees, you go this way. If your angle is greater than or equal to 90 degrees, you go that way. less than 90 degrees. Is the side opposite your angle bigger or smaller than your other side? If it's bigger or equal, you're in this scenario, and there's only one solution. We like that scenario. If it's smaller, then we have to check B sine A. So find B sine A. Is it equal to A, less than A, or greater than A? If it's equal, it's one solution, and you have a right triangle. If it's greater than A, your A doesn't touch the ground, you have no solution. If it's less than, you've got the two solutions. If your A is greater than or equal to 90 degrees, either A is the biggest side, in which case you've got an obtuse triangle, or A is the smaller side, in which case you don't have a triangle at all. So, every time, start, follow the flowchart. I've also formatted the exact same information in choose your own adventure style format. Exact same information, it just doesn't involve the chart, which takes up a lot of space. All right, so is A less than 90 degrees? If yes, go here. Is A less than B? If no, one solution. If yes, go to 3. And then you check the A or the B sine A. If A is greater than or equal to 90 degrees, go here and check the obtuse triangle. So, another way to convey the exact same information. All right, so determine the number of possible solutions for each triangle. All right, so is A less than 90 degrees? Yes. So we're going down that left-hand side of the flowchart. Or on here, we're at yes, go to step 2. Is A less than B? Or side A less than side B? Yes. Go to step 3. So now we do B sine A. So 10 sine 30 is going to be 5. A is greater than B sine A. So that means that we have 2 solutions. Note that this problem doesn't actually tell us to find the 2 solutions. This just wants us to say that we have 2 solutions. For example, number 2, our angle B, is it less than 90 degrees? No. So we skip down to number 4 here. Is the opposite side greater than or equal to the other side? No, that's no solution. So, follow the chart. Find all solutions for each triangle. If no solution exists, write none. So let's first figure out how many solutions there are to this triangle. So A is greater than 90 degrees. So that means go to step 4. A is greater than B. There is one solution. And we do love it when there's one solution. So if there's only one solution, then we just have to straight up use the law of sines the way that we know that it works. So, law of sines, we want to find, first we're going to find angle B. So we have, we're trying to find the angle, so sine B over 3 equals sine of 112 over 4. We're going to multiply both sides by 3, and that's going to cancel that out. So we get that sine B equals 3 sine 112 over 4. That's going to give us the sine of B, but we want B, so we need to use the inverse sine of 3 sine 112 over 4, and you can plug it into your calculator just like that, and that's going to give us about 44 degrees. Now you can do 180 equals 112 plus 44 plus C, and solve for C. C is going to be 24 degrees. So you get 24 degrees here, and now we can do law of sines again to find this missing side. So C over sine of 24 equals 4 over sine 112, multiply by sine 24 on both sides. We're going to get that C equals 4 sine 24 over sine 112, which is 1.75. And there it is. There was one solution. We have solved the triangle. We've got all three angles and all three sides. Switch colors over here. Okay. Here we have angle A is less than 90 degrees. So go to step 2. Side A is less than side C. So go to step 3. We need to try the B. We need to try B sine A, or C sine A in this case. So 50 sine 51 is 38.8. So A is greater than C sine A, so that means 2 solutions. Okay, so to sketch out what this looks like, I like to do it like this. All right, so you've got some side A here. We know angle A is 51 degrees. And we know the side opposite that is 40. It could be this side, or it could be this side. We know we've got some side C that is 50. That's got to be this side. So this is angle C. And angle C could be here, or angle C could be here. And then this is side B, or angle B, which could be either this little angle or could be the whole thing. And then side B could be this, or side B could be the whole thing. So, start with what we know, right? Use the law of sines to find angle C. So, sine 51 over 40 equals sine C over 50. We're going to multiply both sides by 50. So we get sine C equals 50 sine 51 over 40. And we're going to take the inverse of that. So sine inverse of 50 sine 51 over 40 is 50 sine 51 over 40. 76 point, let's call it 76. Okay? So we get, if C is the acute angle here, it would be 76 degrees. On our unit circle, though, there's an angle 76 degrees with some sine. There's also an angle, an obtuse angle with the same sine. And that obtuse angle is going to be 180 minus 76, which would be 104 degrees. And I'm going to erase some of this so that I can keep writing. So we've got one case where C is 76 degrees and one case where C is 104 degrees. And we're going to now continue to use the law of sines and solve these two triangles separately. So in the C is 76 degrees, this is 76 degrees, this is 51 degrees, this side is 40, this side is 50. We now know what angle B is. 180 equals 51 plus 76 plus angle B, which is going to be 53 degrees. So we get B equals 53 degrees, and we can use law of sines again to find that last missing side. So 40 over sine 51 equals B over sine 53. We're going to multiply both sides by sine 53. And we're going to get that B is sine 53 times 40 over sine 51. Which is 41.1. Okay? So we get an angle B, side B, an angle B, and an angle C. We got all the sides and all the angles of our triangle. Or we get that C is 180 minus 76, which is 104 degrees. Now we're in the obtuse triangle. So this is 104. Angle A is still 51. 180 is 104 plus 51 plus B. It's 155, which means that B would be 25. So now we get that angle B is 25 degrees, and we do the law of sines just like we did down here. B over sine 25 equals 40 over sine 51. And so B equals 40 sine 25 over sine 51. And that is 21.8. And so we get two different triangles here. Yes, that's a lot of work. Deal with it. That's all I gotta say about that. Word problem time. Unfortunately, this is the last one in this section. Visitors near a certain national park can tune into a local radio station to find out about the activities that are happening in the park. The transmission tower for the radio station is along Park Road, about 30 miles from the intersection of this road and the interstate. The interstate and the road form a 47-degree angle. If the transmitter has a range of 25 miles, how far along the interstate can the passengers in a car hear the broadcast? So, right, 25 miles, right? If we think about a circle with a radius of 25, wow, that looks like a really good circle, actually. Everyone applaud my art skills right there, right? This stretch of highway here is going to be the part where you're 25 miles or less away from the transmitter. In part X, you're now more than 25 miles away. You can't hear the broadcast. So what we're looking for in this diagram is we are trying to find what y minus x is. And so here we have hopefully been given this triangle, and we're going to use the law of sines to find x and find y. And yes, I did. I just giving myself a lot more space to work here. So we want to find x, and we want to find y. So looking at this, remember this is going to be the acute angle, alpha, and theta is going to be the obtuse angle. Right now we have this one angle, 47 degrees. We've got an opposite side and an opposite, we've got an opposite side and this adjacent side. We can use that to find this angle. We can also use it to find this angle because this 25 is also opposite. So, find our two angles. Use the law of sines. So, we're solving for an angle, so we want to put sine 47 over 25 equals sine, let's start with sine theta, over 30. And we want to solve for theta. So, multiply both sides by 30. 30 sine 47 over 25 equals sine theta. Take the inverse of that. 30 sine 47 over 25. And that is 30 sine 47 over 25. And that is 61.4 degrees. Okay? Now, right, again, on our unit circle, there's some angle 61.4 degrees, but there's also an obtuse angle with that same sign that's going to be 180 minus 61.4. So angle alpha is 180 minus 61.4, which is 118.6. Yeah, 118.6. Okay. So now we've got these two angles. We can find this angle and this angle. So we want to find this angle in order, because we're going to need that to find x. So this smaller angle here is going to be if we're using the alpha. So 180 equals 118.6 plus 47 plus, let's call this angle beta. And that angle is going to be like 14. Uh, 14.4. Okay, so this angle is 14.4. And then we can find x using our law of sines again. So x over sine 14.4 equals, let's go back and use equals 25 over sine 47. Multiply by sine 14.4, multiply by sine 14.4, x equals 25 sine 14.4 over sine 47, which is 8.47. So this side here, x, is 8.47. Remember, what we're trying to find is this distance, which is y minus x. So we found x. Now we need to find y. So this whole distance, now we're looking at this triangle. We're looking at this angle. And I'll call that angle gamma. I'm just using up my Greek letters here. So, right? So, if theta is 61.4, 180 equals, that was an equal sign. 180 equals 61.4 plus 47 plus gamma. That means that this angle that I'm calling gamma is going to be is going to be 71.6. So then we can find the length of side y by using the law of sines again. So y over sine 71.6 equals 25 over sine 47. We're going to get y equals, so we multiply both sides by sine 71.6 times sine 71.6. We're going to get y equals 25 sine 71.6 over sine 47, which turns out to be 32.4. So we found y, we found x. What the question's actually asking for is y minus x. So 32.4 minus, let's call that 8.5. Minus 8.5 is 23.9. Yeah, 23.9. Oh boy, that was a lot of work. Yes, you are going to have one of these on your quiz. We'll practice more of it in class.